Good morning, friends. Today we are going to briefly discuss all the questions of exercise number 1.2, chapter 1 of class 11th maths. I am Ajit Manna, welcome you in this session. Our first question is, which of the following are the examples of null set? As all you guys know, what is null set? Null set is a set having zero element. Zero element means an empty set or no element inside the set. Is set such that it does not have any elements. Okay, coming to question number 1. Question number 1 is saying set of odd natural number divisible by 2 divisible by 2. So can you name such a odd numbers? So odd numbers are basically, if we say about odd numbers are which are not divisible by 2. For example, 1, 3, 5, 7, 9, 11, and odd numbers are not divisible by 2, and they are saying that odd numbers that are divisible by 2. So none of the odd number is divisible by 2. So we get no element inside this. So this is a null set or empty set or void set. Coming to question number 2, set of even prime number. Okay, they are saying even prime number. Okay, prime numbers are those which are divisible by 1 and itself. Prime number are those which are divisible by 1 and itself. So 1 in itself and even number are those which are divisible by 2. Divisible by 2. So the only even prime number we have is 2. So since it contains one element, this is not a void set. Not a void set or null set. Okay. Coming to question number 3. In part number 3, x such that x is a natural number between less than 5 and greater than 7. So if I draw a number line here and I write down the 5 on the number line, so they are saying that this number should be less than 5, means we have to stay on the left side of this number 5, and they are saying it should be greater than 7, so we have to stay on the right side of this number line. So can there be any number which is less than 5 and greater than 7? Definitely we have nothing actually. So C is a null set. It does not have any element. It is a null set. Coming to question number 4, they are saying y such that y is a common point between two parallel lines. So if two parallel lines are here, if you consider two parallel lines like this, they have no common point. But if you consider common parallel lines like this, one over another, the lines are parallel, but the lines are collinear also. So the two collinear lines can be considered as parallel. So it can be null set or it cannot be null set. So in this case, first A, we have actually no common point, so it is a void set. Void set or null set. But in the example number 2, where I consider line AB and line CD is over the line AB and they have infinite number of common points, so this is not a void set. Here you can A point common, B point common, C point common, D point common, so this is not a void set. So question number D, can be void set or null set. We can make a null set or we cannot make a null set or void set. Why? I illustrated you two examples. If two lines are parallel like this, they are so no common point will be there. But if the lines are one over another, they are not null set. Got it? Coming to our question number 2. Question number 2 is saying set of finite and infinite sets. Okay. So coming to first part, we have to finite and infinite. Finite have countable element. You can count the number of elements present in it, and infinite have infinite elements. So we can't count. And countable elements also means you can also refer void set as a finite set. Okay, we can't count elements. There are so many large number of elements that we cannot count. In fact, we don't know the end point of the, we know the starting point but we don't know the end point, or we don't know the end point but we know the starting point. I apparently repeated two sentences similarly, but anyways, coming to question number second, first part, set of months of a year. So I am giving it a name M, and months are what? January, February, March, April, May, June, July, August, September, October, November and December. So we know that it has only 12 elements. We count those 12 elements, so it is a finite set. Coming to question number second, they are saying 1 2 3 dot dot dot. They tell us the starting point but they don't end it, so it is an infinite set. This, they are saying 1 2 3 dot dot dot. We know that it is a natural, it may be a set of a natural number, but since they do not end it this series, so we will say we don't know actually the how many number of elements are inside this set, so we name it as infinite set. Okay, coming to question number 3. Question number 3 is saying 1 2 3 dot 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 and 100. In this case, they tell us the starting point, they tell us the end point, so we exactly know how many elements are present in this set, so it is a finite set. We can count, even there are 100 elements only, finite set. Coming to question number D, they are saying set of positive integers that are greater than 100. So they are saying positive integer 1 2 3 dot, 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 greater than, they are saying also greater than 100. So what are the 100 positive integers that are greater than 100? Are 101 102 dot, 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 dot. All the numbers after 100 and after 100 is a set of all positive integer and they are all greater than 100, but we don't know the end, we don't know the end points of this set, so this is again an infinite set. Coming to our last part of question second, they're saying set of a prime number less than 100. So we definitely have a very less amount of very less set of prime numbers. We actually know that are 2 3 5 and last number is what? 99 is divisible by which? 98 divisible 97, 97 maybe the, okay, can we divide 97 by 9? It is not divisible by 3, but can we divide by 7? 727, no. So last number is our 97. So we know the starting point, we know the end point, that's why it is a finite set. So we just completed the second question. Coming to question number third, state which of the following are finite and infinite. Again, you will have to find out, check or state or tell the finite line or infinite line. They are saying the set of all lines which are parallel to x-axis. So we just draw x-axis and y-axis. Okay, so this is axis. So they are saying set of all parallel lines parallel to x-axis. So how many lines you can draw parallel to x-axis? I can draw a line here, draw a line here, draw a line here. These all lines are actually parallel to x-axis, so it is obviously an infinite set. Why? Because we can draw infinite number of lines parallel to x-axis. Got it? Coming to question number second of this question number third. Question number third, part 2. The set of letters in the English alphabet. Okay, so can you write all the letters of the English alphabet? Okay, A, B, C, D, E, F, G, H, A, I, and X, Y, Z. So you have a definite 26 number of alphabets. So this is an finite set. Okay, if we go to the question number third part, the set of all numbers that are multiple of 5. Okay, so they are saying multiple of 5. Multiple of 5 means it is actually the table of 5, 10, 15, 20, and there are infinite multiples of 5. So we just can't count to how many elements it has, so it is an infinite set. Coming to question number 4, they are saying the set of all animals living on the earth. So again, we don't know the set of all animals in this earth, so it is an infinite set. There are infinite number of animals living on the earth, so it is an infinite set. It is a finite set. Coming to question number 5th, the part of this third question, the set of all circle passing through origin. Okay, so if I draw a coordinate axis, x Cartesian plane, x axis and y axis, how many circles you can draw by taking center here? You can draw this circle, you can draw this circle, you can draw this circle. So in fact you can draw infinite number of circles. So again there you can draw infinite circles over this, taking 0 0 as center. Now they are saying actually circle passing through origin. Actually I draw something else over here. Okay, I'm going to again draw the Cartesian plane, and they are saying circles passing through circle. So this, the periphery of this circle is passing through this. The periphery of this another circle is also passing through origin. The periphery of another circle is passing through origin. So you can draw infinite numbers of circles passing who is passing through origin. So again it is an infinite set. Coming to question number 4, in the following state whether A or B are equal or not. They are saying which of the sets are equal or not. So we will have to check the equality. And what is the rule of equal set? Equal set have the same elements. Same elements in either two sets. Means there should be equal number of elements, and each element should be identical to the another set. So can we find A in the set B? Here it is B, B and B, and C and C, and D and D. So since all the elements of A is present in all in the set B, so we say that A is equals to B. Part second of question number 4. Okay, we will again try to find out the number of elements and also check whether they are present in that. Okay, we find 4 here, 4 here, we find 8 here, 8 here, we find 16 here, we find 16 here, and this element number 12 is exchanged with element number 18, so they are not more equal set. So we write A not equals to B. Coming to part number 3, Okay. Point number 3 is saying set A have 2, 4, 6, 8, 10, and set B has even positive integer less than equals to 10. So what are the even positive integer? Even positive integer are 2, 4, 6, 8, 10. So it has also 2, 4, 8, 6, 8, 10, and it has also 2, 4, 6, 8, 10. So these two sets are equal. So we write A is equals to B. Coming to question number 4. Question number 4 is saying what? X such that X is a multiple of 10. Okay, if we write the multiples of 10 here, 10, 20, 30, 40, dot, 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 infinite set, and here they are giving this set. So can we match over here? 10 is present here, 10 is present here, 20 is present here, 20 is present here, 30 is present here, 30 is present here. But this 15 is not a multiple of 10 and it is not present here. So again, this is not a equal set. A not equals to B. You got my point, guys? Coming to question number 5, are the following pair of sets equal? We will have to again check the equality of two sets and also give the reasons. Okay, they are saying in question number first, they are saying A have two elements 2 and 3, and B is the solution of this equation. So we will have to go and solve this equation. Okay, x square plus 5x plus 6 is equals to 0. We will consider 1 as the coefficient of x square and then multiply these two numbers A and C. We get 6 1s are 6, and we then factorize it. So we get 2 and 3. Can we write 5 as the sum of these factors? 2 plus 3. Okay, so here 1x square plus 2x plus 3x plus 6 is equals to 0. We take x common in from these two, we get x and we get 2, and we get 3 common from this, we get x plus 2 is equals to 0. So x plus 2, and which has two factors, x plus 3. By solving this we get x is equals to minus 2 comma minus 3. So B has the, for problem number 1 they given 1 as 2 comma 3, and B has, we get solution as negative 2 and negative 3. Since 2 is not here, it is actually minus 2. So set A not equals to set B because they do not have same elements. Here's the reason why these two sets are not equal. Coming to question number second over here. Okay, so A is equals to x is that x is a letter of word follow. Okay, we will write set A as FOLW. Okay, then we write x is that x is a letter of word wolf. We just separate all the words separating by comma, enclosing it within a parenthesis. WOLF. Can we find can we check whether those two sets have same elements or not? Here F, here F, here O, here O, here W, here W, here L, here L. So all the elements that are present in set A is already and is also present in set B, and there is no such elements which left to be uncommon. So we say that A is equals to B because all elements of two sets are same. And that's the end of our fifth question. Coming to question number 6, they are saying from the sets select the equal set. We will have to select which of the two sets are equal and which of the two sets are not equal. Okay, see, so to check the equality with A, we will have to find which element has 2. Here 2, here 2, and here 2. So is these two sets are equal? Okay. Okay, After getting 2 in these two sets, we will try to find out the 4. 4 is here, 4 is here, and 4 is here. Then we check 8. 8 is here and 8 is not getting anybody here. So A is not going to be equal in any of the twos, any of the all set which we have actually. Now we will try to check the similarity of B. Okay, so B has 1 2 3 4 and D has 1 2 3 4. So we write our answer as B equal to D. Coming to, is anybody anywhere elsewhere we have this 2? No. Now we will, as we see that set E has -1 and +1 and set G has -1 and +1. So we write set G is similar to set E. So we write G is equals to E, or E is equals to G. None of the other two sets are equal here, and we conclude that only two sets among these 8 sets are equal and others are not equal sets. If we go to A and C, we find 4 8 4 8 and 12, but in set C it has 14 and in set A they have 2, so these two sets are again not equal. If we go to H and F, H and F had 0 common, but F has A and H has 1, so they are again uncommon. And that's all for today. Thanks for watching. We will very soon coming with our next topic, and after that next topic we will continue to video lectures.